there we go. This is nice. I can actually have the comments right there on my screen. That's awesome. Okay, yeah, hello. So good news, I won the fight yesterday. Well, it wasn't a fight, it was just I had an episode. It was just too much for me. So that's like, this morning we tried my routine and we had a really good morning. So that's Christian 1 and girlfriend like 152 or something. She's much better at this family stuff than I am. But yeah, I provide value. It's just not in terms of routines and like the basic stuff. I add the joy. Anyways, so yeah, we played around with the SVG thing yesterday. Hi Etienne. Oh, this is nice. Now I have the comments right there on my screen. That's awesome. Yeah, that makes it more fun and interactive as well. Like you giving me comments and then I just don't respond at all. Anyways, so we did the SVG. One thing I reflected on yesterday is that like we had to paste twice to actually get the thing in there, but that was because we were proof of concepting. So what I would typically do, I wouldn't like write it back to the clipboard. I would actually update the internal state, like as if I got an update from another client, and that would indeed update the Excalibur draw. But yeah, we had the SVG issue. I did create an issue. This. Yeah, as you can see, they even answered me. So that's awesome. So if they fix that, we'll give it give a crack at it, or we'll try it again. And then it should be like super smooth. You should be able to just click hero icons and you can just paste it right into Excalibur. So that's awesome. Yes, but this application I talked about, I'm going to build it with Next.js, and that's just because it's like simplified deployment and all that stuff. And I want to test the React states architecture with Next.js. And what's kind of cool about that is, let's see, Gitbook. So I'm just about to replace a README of React states with this Gitbook. So I got most of it in here now, but it like the API is like downplayed a lot. It's focused on this being an application architecture. It's not like a library that there's like a very like the API exposes how to build it. There's no like create feature or anything like that. It's just a set of helpers to make this architecture work. So I'm going to kind of relaunch React states as a React application architecture for predictable user experiences. That is what React states is. And it happens to have an NPM package with some tiny helpers to help you apply that architecture to your code base. And here I dive into the like the patterns and the abstractions that that's like part of the architecture. Like there's a feature concept, which is basically just a React context provider, and so on. So we're using the React primitives as much as possible with some tiny helpers on top. And then it's all about how do we actually separate our concerns. Like we have an environment, the app is mounted in the environment. We have an environment interface, so the app doesn't know what environment it's running in, and so on and so on. Cool. By the way, I thought about I haven't been coding at Code Sandbox for like over a month, I think, because we're building something pretty epic, and that requires a ton of alignment because there are multiple people working on it and it's complex stuff. So I've been just Excalibur drawing and making videos and going into sessions and resolving like misalignment and lack of context for everyone. which I've learned a ton about. Maybe I should do a presentation on that. Anyways, but I'm back into coding now, so maybe I could stream that as well. I'm having like a coding week at Code Sandbox. Anyways, so I'm not perfectly done here, but at least I got everything in here now. So I'm going to reiterate a couple of times on this documentation, and then I'll do like the official re-announcement. And this is how we are building the new stuff at Code Sandbox. Cool. Okay, so since we're going to use Next.js, I don't want to go into server-side data fetching. It will be interesting, but it's tricky with, like maybe there is some documentation. Firebase, it's the authentication. Like you would have to authenticate on the server. When using Firebase, okay. Oh. Static generation pattern. Oh, this is interesting. Next Firebase auth. Makes it simple to get the authenticated Firebase user and ID token during both client-side and server-side rendering. Oh. Oh. Depending on your app's need, other might work better for you. If your app only uses static period or doesn't need a Firebase user, needs a Firebase user but does not need the ID token server side, you could consider one. Okay, it's complicated. Okay, but we don't want to do this. We could do it, but this is yeah, I don't see the benefit. Like what I do see the benefit of is that we do have server-side rendering, but it's to render the skeleton. So we're not going to do this sign-in page. We're going to actually do this. And this will, let's see. When you go to the dashboard, that is going to be going to /dashboard. So that's going to be a page on its own. And then we should probably call this something else. Admin. Let's call it admin. And then of course this is on slash. Yes. So typically you wouldn't like store slash on your phone or on your iPad. You would like go to one of them and then store that as the app on your home screen. But we are not going to directly load this thing. Oh shit. Oh shit. Okay, let's move that up there. Admin down there, and then we'll move this stuff. I just love the selection of Excalibur. It's so insanely intuitive. So we're going to create another thing here. We're going to create a skeleton. And the interesting thing about this is that we can actually make this a state in our feature, meaning that when you render on the server side, like you have like a server rendered state, like I don't know what to call it, but like initializing or something. And then we have the loading state. So when we're on the server, we are in an initializing state, and it renders exactly the same as the loading state. But the point is that it doesn't run any, or maybe, no wait, we can just do loading state because it doesn't run any side effects on the server anyways. So it won't trigger like the loading of the data. Ah, this is interesting. Yeah, let's try that. So we can just have, like it starts in the loading state, which renders the skeleton. And then it hits the client and it renders the exact same thing, like it hydrates. And then it will actually trigger the effect that actually grabs the data. So I guess, yeah, I guess we can have all of these things, only that they're like faded out or something. Opacity, blah. We'll do something simple. And we can show the current day. That's also nice. Yeah, something like that. Skeleton. And we're going to do the same for the dashboard. Oop. And whoop. And I've actually started, I've not started implementing, but I've started drawing up the, let's see. Let's grab all of this stuff. Oops. All of this stuff. Let's just copy the whole thing. Yeah. There we go. And then we're rather going to use like a gray thing, because we don't have the data there yet. So that kind of shows that we're loading. We can still show the days. Okay, cool. So we're going to try that server-side rendering. As I said, we can just put it in loading state as normal, because that doesn't trigger any side effect in Next.js. I do wonder how React is going to, like, I imagine this with this React states architecture. It's really interesting how you could do server-side rendering, because we only have these features and they could actually run side effects on the server. And the way it would work is that through the application, you're waiting for these features to end up in a specific state. Which means that as long as React has, and the way they can wait for that state is by using suspense. So you can imagine, like, you mount your application into the server environment, which means that it uses the same APIs, but it's like server-side implementation of grabbing the data. So the application doesn't care about this. There's no like if server, if client stuff. It's just a different environment. And then as your application tries to render, it will start suspending because the features aren't in the right state yet. And then as they start resolving, like React probably has some internal state of, do I have any suspending stuff? And when all of them resolves, that's when you get the response to the client. I guess the tricky thing is, like, how does a client know that you, like, what state the feature should start in? Because that on the client, it will start in loading state again, right? But what I mean, there's something there. There's something about not waiting for data, but waiting for these features to move into a specific state. Because then anything can happen in the background. It's not tied to data fetching. Anyways, just reflecting. Cool. So we basically have our mock up and running. Yeah, so what we're also exploring here, this is like part of the React states architecture, is how do you actually approach developing the app? And I find most joy when I sit down with the Excalibur first and think about how I want things to look, like the user flow. And then the next natural step is like, okay, let's create a proof of concept environment where we're going to explore the types for the data that we need and the environment interface that we want our application to use. And when that's done, then we can just start implementing the UI. We don't have to touch any environment specific stuff because everything's provided by the proof of concept environment. And then we keep like iterating on the interface, environment interface, the data types, and implementing the UI. And everything's like super fast, and we can even deploy it and you can test it with users and stuff. But it doesn't persist anything, right? And then when you're happy about that, like the last thing you do is actually implement the browser environment where you connect to Firebase in this case. I find that fascinating. So that's what we're going to explore here. And to do that, See, this is work stuff. Do we have... Oh, I haven't even checked it out here yet. Let's see. So this is called like Family Scrum, and this is version 2. And in this case, it's open source, because the other one, I like had this big plan of creating this family apps where you would pay money and stuff. I actually got everything up and running, but I built it with Flutter. And my girlfriend and me, we actually use this. And it's super, super helpful, at least for us. But I never got to... Oh, shit. I never got to the point where... Like, it's marketing and stuff. I find that really, really tricky. Like, I never had that friend growing up. Like, at Code Sandbox, you have Evis and Bas, who are the founders. And they are, like, the perfect match for running a startup. Because Evis is the technical wizard, and Bas is partly like he's like everything else. Like he does a bit of design. He really enjoys finding good ways to do management in a way that's not like about clever solutions in management, but finding solutions that actually works for people. And both of them, they communicate really, really well, even in stressful times. And I never had that friend growing up who could like, what's it called? What's it called when you have one person and the other person kind of completes the other person without being so romantic? You know, there's a term for that. I don't know. Anyways, so in a different universe, I would actually be running a startup at an early age, I think. But it's nice to be part of one now, with all the experience of going through like consulting, building teams, building culture. Like that's super difficult to do. So I will probably fail as a startup, but I really believe in Code Sandbox. It's the right people at the right time, I think. Building the right thing. So yeah, this year is going to be super exciting. What do I do now? Yeah, yarn. Sorry. Let's see. Okay. Moving from coffee to water. Let's open this properly. Development, family scrum. Cool. Okay, so let me show you what I've done here. I've created the interface for authentication. And with the React States architecture, you don't return promises, you return results. And this gives strong typing on dealing with errors. Currently, there is only one authentication error. I have to look at the Firebase documentation. And I actually consider making, like if you're not logged in, I consider that, so when you authenticate, I consider, I consider it an error if you're not authenticated. Like if there's a user there or not, that's also a way to, but it's not very explicit, is it? So let's try that. So either you get like a general error, or you will get type not authenticated. Yeah, so you type both. Like that's the thing with TypeScript and JavaScript. Like try catch, it's horrible. You can't type the errors and don't know if you're dealing with all the errors, what errors can be thrown. There's no difference between runtime errors, like I mean JavaScript runtime errors and errors coming from the API. And it's just horrible. Yeah, so we have that, and the proof of concept is basically all the environments or environment effects. They are behind a factory so that you can configure them. That's just a pattern. So we are creating the auth environment effect here, and we're using proof of concept. So I have a hard-coded user. I'm actually using Bob Saget. And then we just return that as a result, async result. Cool. So what I've been exploring is the storage. And I've done something wrong here. I put it on the wrong side. So let's see. Add grocery, and that should be, what was the interface for that? Add grocery, category and name. Category and name. And this returns our result. I've been completely, let's see, async. Yeah, I was messing around with it. There we go. So here we have the storage, and since it's a proof of concept, I'm just adding some users here. Not using them currently. Maybe I don't. Yeah, we do need them. And I'm playing around with, we can look at the interface first. So we have like a storage error. We have a family that we want to grab data about. We have the grocery categories. We have a grocery. We have a task, and we have a week. And the interesting thing is that I'm not now thinking about how this is stored in Firebase. I don't care how this is stored in Firebase. This is how I want to consume a week in my app. And when way down the line, when we actually create the browser environment, we just have to make sure that Firebase is able to produce this week. However it does that, I don't freaking care. And this is what often happens. It's like you implement your application and you structure your data related to how it looks on the server. So you're thinking two things and you're trying to align these two things. And I don't think that's a good idea. What I like about this approach is that you only think about the application, like you start with the user flow, and then you think about the optimal data format to consume, to produce that user flow. And then you're actually able to deploy and test this without persistence with your users, getting feedback, improving the solution. And then when you're happy with it, then you actually start thinking about, okay, how are we going to provide the actual data for this? And as long as you adhere to this environment interface, the application will just work. That's the cool thing. Now, I'm not saying that you won't hit a problem doing it that way. Maybe you have to think about how the data is structured on the server to optimally provide it to the user. For example, there is this thing in the app where you toggle which days of this week are you going to do this task. And it might not be optimal that every time you tap this, the whole data structure updates. You probably just want this to update. Or something like that. I don't know. So we might hit a few bumps, but that's why we're exploring it. Okay, cool. So now we had add grocery. I want to be able to delete a grocery, and I guess we'll just delete grocery. We just need the ID of the grocery there, and it returns a result of well, nothing. And then we want to, I can go more into why I structure the data this way later. And then we need to get family, and we need to get the, well, first of all, we need to get the user. Oh, that's interesting. So when we authenticate, this user should have a family ID. And now I'm saying you have to have a family ID. The previous version of like Family Scrum version 1 allowed you to use the app as a single person, so you could like try it out. I don't care about that now. You have to set up a family to to actually use it now, just for simplicity's sake. Okay, so we have a family ID. Yes, we need a family ID here, 456. And when we get family, we get the family, I can say ID. And what we should get back here is an actual family or a storage error. And a typical thing here would be like not found. Like that's a generic error for storages, is that you're trying to grab something or and you have like no access and stuff like that. Yeah, so you would, storage read, let's see. Export type storage read error would be type not found, and then storage type no access would be one. Storage write error would be I don't know, what would this be? So not found is read, and when you try to write and it doesn't work, I guess it's, yeah. So get grocery storage error or storage read error. It's the same for getting the tasks. Get week, same thing. Delete, get family, same thing. Okay, so yeah, so but we're basically just describing our API here. So I want to get a family. I want to, what else do we need? Get week. Yeah, so we also need to get the users. Well, no, that's part of the family. Yeah. Yes. Let's see. So yeah, so we're missing a family here. Family. Four, five, six. And the users. Yeah, so this is more the way I thought about it. So we don't actually load the users, we just load the family, and that holds the users. We don't need the ID of that user. Yeah, this should have an avatar. Maybe we can find a funny image. Funny avatar. That wasn't funny. That one was funny. Oh, I'm going to spend more time on this. Let's not have an avatar. Oh, of course. There we go. These are like generic and boring. Okay, let's use these two. This is Bob Saget. Copy image address. Oh shit, that was a long address. There we go. And then let's use, was it this one? OMG, I can't believe I'm... Okay, whatever. Let's use this one. Copy image address. Okay, let's try that. Cool. So we have a family now. Now we just need to be able to delete a grocery, and let's implement deleting that grocery. So let's just do let groceries, and then we'll just say groceries equals groceries. Filter. Why is it so difficult for me to write grocery? A result. Oh, I'm doing this wrong every time. This is the result. Async okay. Return okay. It's supposed to be void, and hopefully that works. And then we have get family, which is also an ID. And I love like doing this kind of having this interface of the environment effect here, and then you implement for each environment. You can just point to the type, and then everything is inferred here. You see that it understands everything's a string, and you just kind of fill in the blanks. It's really, really nice. So we do an async. Yeah, and this would be like okay family. Cool. Yeah, so you can't really you just get a family here, or the default family. Okay, so that's ready. So now we have a family. What else do we need? So we have well, we do have to be able to like increase the shop count of a grocery. Increase it and decrease it. Yeah, and I don't think we'd like need increase, decrease. Maybe we should. No, because then we can debounce. Like if you tap twice fast, we can like, yeah. I think rather setting the shop count. That's better. Okay, back to the interface. Set grocery shop count. ID string shop count would be a number. And I guess, does this need to return anything? Like it could return the grocery with the new shop count, but we're optimistically changing it anyways. No, I think we should return it because you want to validate that you actually saved it, so that if something goes wrong, it will kind of reset the account, which is a bad user experience. Like you go to 4 and then suddenly it's back to 0 because something went wrong saving it, but then there should be like a notification there. So I think we should return a grocery here. Yeah, and I think we should have storage write error. Write error. Yeah, I think we should be explicit about that. So add grocery would be a storage error or a write error. This would also be a write error, and this would be possibly a write error. Because we want to be explicit about that error. We want to say that, like, we could not find it, and when you write something, we want to be explicit that we weren't able to write it, which means like you can try again, for example. It's not just an error. It's explicit. Cool. And we have add grocery, delete grocery. We have add task. Yeah, we need, yeah, I'm not sure if we're going to have delete task, but we're going to have archive task. And this is a result. Yeah, I think storage error or storage, right? Error. Yeah, and what we can do here is storage read error is storage error, or we can do this storage. So we don't have to like use that. It seems unnecessary. Like they all extend storage error. So if something unknown happens, that's always possible. Cool. That's it. And then, okay, what else do we need? Oh, did I do something wrong? Oh yeah, we added the new thing. So we have save, cancel. Yeah, and of course we have toggling the week, like changing the week. And the question is, what happens? When happens when you tap this thing? Does it replace the whole week? And this is interesting because at this point there might be 2 users working on this. And I had a couple of challenges when I implemented this the first time to give a good experience. Like the first time you could only manipulate your own thing. And the conceptual idea there was that you have to tap it because you are committing to it. But then we had situations where like I couldn't find my phone or my girlfriend couldn't find her phone. And then we wanted to be able to adjust each other's commitment. But the problem then is like when I could only manipulate my own thing, I could just like tap like crazy. It could move really, really fast because I was the only one manipulating that piece of data. But when I can manipulate both of them, we would get into situations where she would like change hers and I would change the same. And then it didn't trigger like, cause she turned it on and I turned it off and stuff like that. And yeah, we can solve that with just not having like OMG. Like not toggle it, but we actually set it. So if I toggle it and she toggles it at the same time, we're both setting it. So we'll end up with the same result. And I think we're going to try that just for simplicity's sake, is that we're going to optimistically update it. And yeah, this is the tricky part, because if we do it optimistically, like when do we have eventual consistency? When do we have eventual consistency? So we could do like a debounce thing, because that's also typical. Like you're doing like a task every other day, for example, so you kind of just tap through it. So if we had a debounce of a second, for example, we would kind of just optimistically update those, and then we would send the whole week to the server. And then when it gets back, we'll actually update it. Yeah. But that's also a thing. Like if you have like 20 tasks there, and we send the whole thing to Firebase every time, when it gets back, it will update the whole thing. So it will need to reconcile the whole freaking list, which is not ideal either. So we should update individual tasks. Oh, this is interesting. And that's not really supported by, yeah, I said I'm not going to care about the database, how it's structured. I just want to update my stuff. But this is triggered from reconciliation in React, right? We really want to yeah. Well, what we can do is we can say like set wait a minute. This is the wrong data structure. Oh, this is the wrong. Oh, interesting. So these are the tasks. Oh, I'm missing. Oh, wait, this is a bad data structure. Let's look at this. So the way this is stored, or I want this to be stored, is like you have a week and that has an ID. As you can see here, it's the year, the month. It's actually, yeah, and the day or the date. That's the ID of it. And then you have tasks. And that should, of course, be like this. Task ID, string, and then we have, like that reflects the UI, right? You have the task and then you have the users. Yeah, and we don't have like this, we just have a boolean. No, wait. We do have this thing, but we have boolean, 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 boolean. So 1, 2, 3, 4, 5, 6, 7. Oh, did I? Where is it wrong now? Oh, there we go. Okay, so each user, each day of the week, which holds a boolean if it is active or not. Okay, so what I'm thinking is that we'll introduce like set task, like set task on day or something like that. And what it does is that it returns the updated array for that specific user. So it doesn't return the whole week, even though we're updating the whole week in the database. We don't care about that. We just want to update this array. So we'll create an API that does that, and it will return a new representation of that array. And that's the eventual consistency. So what we'll do on the client is like you can tap through that, updating this array, and then on debounds 1 second, that's passed to the server, and then it saves it. It gets back the updated data, and will and that will probably be the full week when we look ahead and implement this for the browser. But then we'll go in and we'll actually grab that specific array, and that's what we return from the environment effect. And we update our state with that. So that means that we don't have to reconcile everything. We just have to reconcile like that specific task on that specific user. There it is. Cool. And the reason I type it like this is because it should be an array of exactly 7 values where you have a true or false. Like I could change this to be like an object where you had like a key is the day and stuff like that. But I think this is just, it's more friendly for the UI. We just iterate, like we have an index of days, we have an index of booleans, we can just look up directly. So I want my environment interface to be UI friendly, like implementing the UI. The data format should be structured for implementing the UI, not the other way around. And I think we often do this where we rather think about what the environment provides, and then the UI implementation has to adjust to that. I think it should be completely opposite. The UI implementation, like looking from the UI and backwards to the actual environment, that should dictate how the environment provides its information. And that's why we have this environment interface. Cool. So we have archive task, and then we also need set And let's give this an actual type. What should we call this? Task. Task week. Task week activity. Activity task. Task. Week task activity. Yeah, I think we'll call it that. Export type week task activity. And that's this array. If the task is active or not. Okay, cool. Yes, week task activity, and then we say set week task activity, and that's going to take the ID of the task, and then it's going to take the set week and then task activity, week task activity. Like that, and it returns a result of week task activity, right? And then storage write error. This is nice. This is super nice. Yeah, I have to go to a meeting in like 10 minutes. Yeah, I thanks for the comment on the rants. Yeah, I like to rant, and as I mentioned yesterday, I realized it's a way for me to get into the coding, because I have to. It's like cleaning out my head to get into focus mode, and it's also for me to kind of deal with life. I have to put things into perspective, and doing like a rant on how I experience things. Because at the moment, I might feel like life is horrible. I don't want to. I don't like how this is going. But it's like in the moment, like you're just frustrated, maybe like hungry, tired, and all that stuff. And then when you get some distance, you kind of realize that it's so typical. It's something you would see in like an episode of some family comedy show kind of thing. So yeah. Yeah, it sounds healthy. Yeah, it works for me at least, and I'm glad it's useful. Set week task activity. Yes, so this is when we're toggling this stuff. So now we have an environment effect for that. And there's no like creating a family and adding and removing family members and stuff here, but we're not going to deal with that in the first version. It's actually quite cool how it worked in the first version. It's like a screen where, so you create a family in the UI, and then you go and you invite a family member. And the only thing the other person has to do is to click join. How was that? Yeah, so you say like invite family member, and you get like a 4-digit code, and then the other person just has to open a screen and type those 4 digits. But there's like a, what's it called? Like a expiration on that, which is basically just a few, or was it? I think I even did it without the code. Anyways, that's the experience I want. I want someone to like create a family, just go into a screen where they say invite family, and then like using time constraint, you kind of automatically just join a family. So one way to do that would be like, okay, there are 4 pictures, So I say invite family member, there are 4 pictures, and then I choose one of the pictures, and then the other person, oh yeah, no, that wouldn't work. Oh yeah. Well, it wouldn't be 4 pictures, it would be way more pictures. Like so there's like a database of 100 pictures, and then you show 10 of them, and it's based on time constraints, right? So every 30 seconds or something, or every minute, it moves to 10 other pictures. So you have like about a minute, like maximum 1 minute to sync up, meaning that both of you see the same set of pictures and you have to tap the same picture, and that connects you, which is kind of cool. And like the likelihood of someone else trying to join a family and tapping the same picture within 1 minute, like within 1 minute, that's like, and even not within 1 minute, it's within the time you click the picture and the other person clicks the picture, right? So it's like insanely unlikely that could happen, but the onboarding process is like super simple. You don't need an email address, send an email, join, and all that stuff. I really hate that flow. Anyways, that's for later. Okay, so I think we should just finish this by implementing the proof of concept for toggling this stuff. And now it starts yelling here. So this should be, yeah, so this should be like task 1. False, 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 true, false, something like that. Oh, 1, 2, 3, 4, 5, 6, 7. And then we'll do like true, false, something like that. And then maybe, okay, so we only have for 1 task for now. We can play around with that later. Cool. And then let's implement, yes, we'll finish this proof of concept, and then what we can do tomorrow is to actually start implementing the UI. And I'm using Tailwind CSS, and I hope that will help us. Like, it will look pretty okay without us spending too much time. Because that's what I noticed doing streams and building apps. I spend too much time when I do CSS and JS to build the elements. Like, you have to like create an additional definition and stuff, and I think we'll move way faster by just adding class names. So it's not that I think CSS and JS is bad. It's just a part. It's just part of making a better stream, like not spending too much time on UI, because that's not what we're exploring. We're moving from so we're building new stuff at Code Sandbox, and there's a long history. Like the Code Sandbox client has become a legacy thing. It has become a legacy thing, and we have this window of opportunity now, building a big new thing. So we had to make a choice. Do we continue with Overmind, or do we do something new? And Overmind has it's been better every time. So we started with Redux, then we moved to Cerebral. It cleaned up a ton of stuff, and we moved to Overmind after that, which got us like TypeScript support. But there are still things about Overmind that it doesn't deal with that well, and it's basically related to like dealing with async stuff, disposing of stuff. So when you like move around as a user, you you do a lot of tricky, well, not tricky stuff, but you do a lot of stuff that triggers side effects. And in Overmind, it will just trigger those side effects. And those side effects will kind of run until its end, and the logic will continue. And we don't want to do that. That's not ideal. We want to, as the user moves around, trigger side effects and does things that should stop the existing logic from running, that should just automatically work, so that it's more predictable. So an example of this is like in Code Sandbox, where when you're on the dashboard and you load like a workspace on the dashboard, and then you move to a different workspace, you will likely see the wrong workspace there. This is a typical thing because we're not stopping the other loading of the other workspace. So it overrides it. Very typical. Anyways, so that's one thing. Like, we have a few things that we wanted to fix, and then there's also the implementation of the UI. We have quite a few complex components, and we really want a really strong concept around building a UI component. And with the React States architecture, the only thing you have to deal with building UI is these explicit states, and you can dispatch actions. There's no calling imperative APIs, driving logic from the UI. You only consume these explicit states, and you dispatch intents of doing things. And then it's up to the feature, as it's called here, to actually deal with this. So that makes them way simpler. And then when you have these explicit states that the UI is consuming, where did I put the... I have a really nice... Let's see. Scully draw. So another thing that happens... Here we go. Yeah, as you can see here, when you have these explicit states in the UI, we with the help of TypeScript, we can make sure, first of all, if you do something wrong with the implementation, which means that you have to look at this. We have a lot of null checking in Overmind, because you just define your state, and for example, a user, you might have a user or you might not have a user, and this is true for most of our data. It might be there or it might not be there. So you have a lot of, you have a user or you have null, you have this or you have null, and it's just tiring when you implement a UI and you know there is a user there. There's no way this component could be implemented without that user. So the way this works is that you rather check the state of the feature if it's, for example, authenticated, and then you know the user is there. You don't have this concept of either user, either you have a user or you don't have a user. You just have states, and on authenticated state you have that user. And the point is that that makes the implementation way more predictable, that you don't point to a user that might be there or might not be there, and then it's just wrong, like your assumption was wrong. It will ensure that doesn't happen. But it will also ensure that when you consume a feature and that feature has multiple states, you're not missing out on any states, because that also can happen quite often, is that you just have a bunch of state values, and then you have a component where you just consume some of these state values, and implicitly there's some hidden state there. And your mental model of how this UI should work didn't consider that implicit state. So now your UI component doesn't even handle a certain situation in the application, and it doesn't make sense to the user. But with these explicit states, we can also notify you if you're missing an implementation. So that's what it means to match on explicit state, is that you say, I want to match on this feature, and then it forces you to implement everything, like it forces you to implement something for every possible state of that feature. And I'll show a ton of that stuff. But yeah, this was a really bad explanation. But yeah, if you saw the video, it really points to the issue. And this React States architecture is built on the concepts from that video, but it embraces React, the React primitives. And that's kind of the last part of this story, is that we are going to hire quite a few people, and it makes more sense for us to have a React-focused architecture where we just have some certain patterns, best practices, and abstractions, rather than having like some state management tool where they would have to learn the API of that. Now they just, if they know React, they will be able to use this architecture. Yeah, that's the point. Oh, now we've gone over time. Let's see. Okay, we don't have time. Let's implement this tomorrow. Implement last pieces of API. Okay, cool. Let's just commit this. More API surface or environment or environment interface. Okay, but yeah, tomorrow we'll finish that, and then we can start actually implementing the UI, and we'll see which direction we go. If we go to the existing stuff or we do this dashboard thing. Cool. And then we'll actually start implementing features, and you'll see more how this React States architecture works. But yeah, if you're curious, I can put, let's see, React States share. Like this is open, so I can put it on put it here if you're curious. Like this is a work in progress, but yeah. I'm going to replace the README of React States with a link to this Gitbook shortly. Okay, cool. Thanks for following along. Yeah, and I'm excited tomorrow to actually get moving with this. Like it feels right already to have this approach to building apps. And I think I've thought about this process of taking your time with the UI, the flow, kind of proof of concept. Like we have this idea of this flow. This is nothing new, but I think we don't have any way, like it's a discipline, and discipline is really, really hard. It's much easier to discipline yourself when you're forced to think about things a certain way. Like the tools forces you to think about things a certain way. It's just like the explicit states concept. Like it forces you to think about the actual states. Like you have to type it, which forces you to actually name the types and everything. Yeah. Anyways, we'll talk more about this. Hello, crazy Saxons. We're just finishing up here. But yeah, we'll continue tomorrow, and have a nice day. And yeah, talk to you later. Bye-bye.